Let's take a look at this chapter. First section is section 5.1, Systems of Linear Equations in Two Variables. And we have, let's see, 2x plus 3y is equal to, let's say 8. And y minus 7x is equal to -5. And we want to talk about how to solve this using substitution. Now this is specifically for a two equations, two variables setup. So solving systems of equations, two equations, two variables, using substitution. Step 1. Solve one of the equations for one of the variables. Step 2. Plug this into the other equation and solve. And step 3, plug the values from step 2 into the equation from step 1 and solve. Okay, so we're going to solve this one using substitution. So step 1. Solve one of the equations for one of the variables. Doesn't matter which one you pick. I'll pick the second one. The reason why this one looks easier to me is there's no number in front of the y. Now to solve this for one of the variables, I take -7x to the right side. So we've got y is equal to 7x minus 5. Step 2. Plug this into the other equation and solve. Well, right here we said y is equal to 7x minus 5. So we're going to replace the y here with 7x minus 5. So we've got 2x plus 3 times 7x minus 5 is equal to 8. Three times 7 gives us 21x. 3 times -5 is -15. Is equal to 8. And solve it. 2x plus 21x is 23x. And take the -15 over and becomes a positive 15. So you got 23x is equal to 23. And then divide both sides by 23. And we end up with x is equal to 1. Step 2, or step 3. Plug the value from step 2 into the equation from step 1 and solve. Now the equation from step 1 will always be the best one to plug it into because it'll always be solved for the other variable already. So we've got y is equal to 7x minus 5, and we just said x is equal to 1. So we've got y is equal to 7 times 1 minus 5. Y is equal to 7 minus 5, or y is equal to 2. So our answer is going to be 1, 2. You put your x first, comma, and then your y. Now substitution works out well, and we're specifically talking about two equations, two variables. It works out well if either you have one of the variables already by itself, or there's no number in front of one of the variables. And see how there's no number in front of this y here? That's why substitution would be a good choice in this one. It wouldn't have to be your only choice, but it's a decent choice. So let me erase that. Then let's take a look at another one. I never put this one into steps. Usually by doing that it makes it harder. Okay. Now I'm going to solve this using the addition method. Some books call it the elimination method. What it means is we want to add these equations together. But in order for it to actually accomplish something, like let me show you. 2x plus 5x is 7x. Negative 3y plus y is negative 2y. And negative 4 plus 7 is 3. That's why it's called the addition method. You add them together. Now the elimination method is because you're hoping one of the variables will be eliminated. Well, there's no variable eliminated, so we have to do something before we can add them. In order for them to be eliminated, they have to have the same number in front of them. Like on the y here, notice this has a 3. We also need to have a 3 here. And they have to be different signs. Well, they're already different signs. This one's a negative, this one's a positive. So what we're going to do is we're going to multiply our second equation by 3 in order to get the same number here. Okay, first equation remains as is. 3 times 5x is 15x. 3 times y is 3y. And 3 times 7 is 21. Now I want to add them. 2x plus 15x is 17x. Negative 3y plus 3y cancels. It's eliminated. Negative 4 plus 21 is 17. Again, we added them, the like terms, and the goal was to eliminate one of the variables, which we just did. So you got 17x equals 17. I'll divide both sides by 17. And we get x equal to 1. Now at this point we need a y, and we're going to plug it back into one of our equations. Doesn't matter which one. I'll plug in the second one. It looks a little bit easier because there's no number in front of the y. So x is 1 plus y is equal to 7. So we got 5 plus y is equal to 7. Take the 5 over, and we get y is equal to 2 again. So our answer will be 1, 2. Although I won't finish this next problem, I'm going to do the first step so you can see the thought process. Let's say I was going to use addition elimination again. And I got 2x plus 3y is equal to 7, and I got 4x plus 5y is equal to 3. Now let's say I'm going to eliminate the y's. To figure out what to multiply it by, for my first equation, you can always multiply by the other number. So we'll multiply this by 5. And for this, we'll multiply by the other number. So we're going to multiply this by 3. Now if they're the same signs, you have to throw a negative in somewhere. It doesn't matter where, but I'll throw a negative in with the 3. So then 5 times 2x is 10x. 5 times 3y is 15y. 5 times 7 is 35. Negative 3 times 4x is negative 12x. Negative 3 times 5y is negative 15y. Negative 3 times 3 is negative 9. And now if we were to add them, 10x minus 12x is negative 2x. 35 minus 9 is 26. That actually works out halfway nice. Well, maybe I will finish it. Divide both sides by negative 2. Then we get x is equal to negative 13. Now we want to plug that back into one of our equations. Doesn't matter which one. So I got 2x plus 3y is equal to 7. We just said x is negative 13. So you got 2 times negative 13 plus 3y is equal to 7. That's negative 26 plus 3y is equal to 7. Take the negative 26 over, it becomes a positive 26. That gives us 33. Divide both sides by 3. I better go buy a lottery ticket. Usually when I just make numbers up, it doesn't come out the nice integer answers. This will be my lucky day. So our answer be negative 13, comma 11. Now that's our first section here. And there's more to it than that, but you can watch the YouTube video and get more of the in-depth. So let's go down to 3 equations and 3 variables. Those are not so easy, but we'll see them. And I'm going to go ahead and plan out my answers to begin with. So, okay, so let's say we got 2x minus y plus 3z. We got x plus 5y minus z equals. And we got x plus y plus z equals. Okay, so if I put 1 in here, that's 2 minus 2 equals negative 3. 1 here, 2 here, that's 10, 11, 12. And 3 minus 1 is 2. Let me double check that. 2 minus 2, 0. Negative 3. 1, 11, 12. 3 minus 1 is 2. Okay. First off, this is equation 1. This is equation 2. And this is equation 3. This is solving a system of equations. 3 equations, 3 variables. Step 1. Group equations 1 and 2 together. Group equations 2 and 3 together. And eliminate the z's. Let's do that first. Okay, so step 1. I want to group the E1 and E2 together. So we got 2x minus y plus 3z is equal to negative 3. And x plus 5y minus z is equal to 12. And I also want to group x plus 5y minus z is equal to 12. And x plus y plus z is equal to 2. Now we want to eliminate the z's. Now this one looks like it's in good shape. Negative z plus z would cancel. This one though, I need a 3 here. So I'll multiply my second equation by 3. So I'm going to have 2x minus y plus 3z is equal to negative 3. 3 times x is 3x. 3 times 5y is 15y. 3 times negative z is negative 3z. And 3 times 12 is 36. Okay. 2x plus 3x is 5x. Negative y plus 15y is 14y. 3z minus 3z cancels. Negative 3 plus 36 is 33. Now I also want to add these two together. X plus x is 2x. 5y plus y is 6y. Negative z plus z cancels. 12 plus 2 is 14. And if all of your terms are divisible by the same number, you do so. These are all divisible by 2. So 2 divided by 2 is 1, or 1x or x. 6 divided by 2 is 3, so we got 3y, and 14 divided by 2 is 7. Now this will be equation 4, and this will now be equation 5. Step 2. Group equations 4 and 5 together and eliminate the y's. So we're going to have 5x plus 14y is equal to 33, and x plus 3y is equal to 7. This problem is a little bit easier if we work at eliminating the x's, but I like to give a step-by-step approach that works 100% of the time, and it's fairly easy to follow. Well, we have to multiply both equations, and to figure out what number to multiply by, remember it's always by the other number. So we'll multiply this one by 14, and we'll multiply this one by 3. Now since they're the same signs, you have to throw a negative in somewhere, so I'll throw a negative 3. Negative 3 times 5x is negative 15x. Negative 3 times 14y is negative 42y. Negative 3 times 33 is negative 99. And then 14 times x is 14x. 14 times y is 42y. And 14 times 7 is 98. We're going to add these together. Negative 15x plus 14x is negative 1x or negative x. Negative 42y plus 42y cancels. Negative 99 plus 98 is negative 1. And this is now going to be equation 5. Try it again. Equation 6. We already got an equation 5. Okay. Step 3. Solve equation 6 for x. Well, in this one, we're going to divide both sides by negative 1, and we get x is equal to positive 1. Now, plug the x value from step 3 into either equation 4 or equation 5 and solve for y. Step 3, solve for x. So step 4. Doesn't matter which one you plug it into. I'm going to plug it into this, the fifth equation. X plus 3y is equal to 7. That looks easier. We just said x is equal to 1, so I'll plug 1 in for x. Plus 3y is equal to 7. Take the 1 over. We get 7 minus 1, which is 6. And divide both sides by 3. And we get y is equal to 2. Now plug the x value. Let me think about this. Plug the x value from step 2. I'm in step 3. Okay, in either equation 4 or 5 and solve. Now plug the x value from step 3 and the y value from step 4 into equation 1, 2, or 3 and solve for z. Doesn't matter which one you pick. I'll pick this last one. X plus y plus z is equal to 2. So x plus y plus z is equal to 2. We just said in step 3 that x is 1. And we said in step 4 that y is 2 plus z is equal to 2. So we got 3 plus z is equal to 2. We're solving for z now. So I take 3 over. We get z is equal to 2 minus 3, or z is equal to negative 1. Now how you write your answer, is you put your x, and then your y, and then your z. And that would be your answer. Now the YouTube videos will show you how to do these on the calculator if you have a TA3, TA4. So I definitely recommend watching those YouTube videos. You'll find the calculator is so much easier than what you just seen. You might argue that this doesn't seem that hard. Well, that's because I'm designing them to come out nice. I picked x, y, and z. They were all integers. If you have fractions, these become hideous problems. Okay, that was systems linear equations in 3 variables. Now partial fraction decomposition. Let's talk about that. Let me clear this off. Now up to now we've been looking at problems that look like this. We got perhaps 2 over x plus 3 plus 7 over x minus 1. And we get a common denominator, which would be x plus 3 times x minus 1. Now here we had a 2, and we multiplied the bottom part by x minus 1, so we multiplied the top part by x minus 1. Here we multiply the bottom part by x plus 3, so we multiply the top part by x plus 3. And I won't go through all the specifics, but we end up with 9x. 21 minus 2 is 19 over x plus 3, x minus 1, which is also 9x plus 19 over x squared plus 2x minus 3. Well, partial fraction decomposition means you're going backwards. You're starting here and you want to end up with your 2 fractions here. Okay, well, we have 9x plus 19 over x squared plus 2x minus 3. And we want to factor that. So that gives us 9x plus 19 over x plus 3, x minus 1. And that just comes from this. Now since these are distinct, unique, different, linear factors, then I'm going to set that equal to a over x plus 3 plus b over x minus 1. So we want to split them into 2 separate fractions. The a and b represent numbers we don't know yet. I mean, we can look up here and see it should be 2 and 7. Well, we want to solve this. So we want to get rid of the fraction. So we multiply everything by the LCM of all your denominators. So I multiply both sides, or everything, by x plus 3, x minus 1. Now when we multiply the right side by that, we multiply each individual fraction. When we do that, these x plus 3's cancel, these x minus 1's cancel, these x plus 3's cancel, and these x minus 1's cancel. So then we're left with 9x plus 19 equals, now multiply this through distributive property, a times x is ax, a times negative 1 is negative a, b times x is bx, and b times 3 is 3b. So we got 9x plus 19 equals ax plus bx minus a plus 3b. So we got 9x plus 19, and if we factor out an x, but I'll put it behind it, we got a plus b times x minus a plus 3b. Well, we want to set these equal. to whatever number's in front of our x, which in this case is a plus b. In this case is 9. So we're going to have a plus b is equal to 9. And then we'll set our constant portions equal to each other. So we got negative a plus 3b is equal to 19. Now this is in perfect form for the addition method because we see the a's will drop away. A minus a drops away. B plus 3b is 4b. 9 plus 19 is 28. Then divide both sides by 4. And we get b is equal to 7. Now we want to plug that back in one of these equations. I'll plug it in the first one. A plus b is equal to 9. And we just said b is 7. So take 7 over. We got 9 minus 7, or a is equal to 2. So now that we know a and b, we can plug it in up here. And this is going to give us 2 over x plus 3 plus 7 over x minus 1. And that would be our answer, which we know from the fact that we started off with that, that's what we should get. Now there's other variations of this. This is where you got two linear factors, unique unilinear factors in your denominator. There's ones where you have repeated, where you have like x minus 3 in one fraction and x minus 3 squared in another one. You have quadratic. So this, if you look in the book, you'll see all the different combinations of that. But that's the general idea in that. I'm going to clear that off. And now let's take a look at it. Systems of nonlinear equations in two variables. Now there's a substitution method and there's also the addition method. And let's see. Let me see if I can find an example of this. I'm not very good at making these up. That would be in 5.5. No, 5.4. This is out of a different book, so don't think this connects to your book. Okay, so let's take a look at this problem. We got y is equal to x squared minus 5x plus 2. And we got 4x minus y is equal to 12. Well, this is nonlinear, which means we have an x squared. So you can't use the methods we looked at before this. So solving nonlinear system of equations using substitution. Step 1. Solve the equation with the smallest powers for the variable with the smallest power. Step 2, plug this into the other equation and solve. And step 3, plug the value from step 2 into the equation from step 1 and solve. Okay, step 1. Solve the equation with the smallest powers for the variable with the smallest power. Well, our equation with the smallest power is the second one. Everything's the first power. So we've got 4x minus y is equal to 12. And actually, both of them are the same. They both have the first power. So we're going to solve for either variable, whichever one looks easier to you. Since the y does not have a number in front of it, the y is actually the easier one. So I'm going to take my negative y to the right side, and I'll take my 12 to the left side. So I've got 4x minus 12 is equal to y. Now step 2, plug this into the other equation and solve. Our other equation is y is equal to x squared minus 5x plus 2. And we just said y is equal to 4x minus 12. So we're going to replace the y here with 4x minus 12. Now to solve this, this is a quadratic. We got an x squared, so we want to get everything over one side and 0 on the other. So take negative 12 over, take the 4x over. So we get x squared minus 5x minus 4x plus 2 plus 12. This gives us x squared minus 9x plus 14. Now this will factor using the PSD. So factors is x minus 2 times x minus 7. Now zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0, and I'll set x minus 7 equal to 0, which gives us 2 and 7. Step 3, plug the values from step 2 into the equation from step 1 and solve. This equation from step 1 will always be the best choice because it will always be solved for the other variable. So I'm going to have y is equal to 4 times 2 minus 12, or 8 minus 12, which gives us negative 4. So this answer will be 2, negative 4. Now for this one, I'll plug 7 in. So I got 4 times 7 minus 12. So 28 minus 12, or 16. So that answer will be 7, 16. Now that's a substitution method. Let's take a look at the addition method now. Let's take a look at this one. Let me clear this off. You got x squared minus y squared equals 12. Then we got x squared plus y squared is equal to 20. Now this is the addition method. The reason why this one works well with the addition method is they look almost exactly alike. They both have x squared, both have y squared, both have numbers on the right side. If they look different, see how this is an x squared but this doesn't have an x squared? Typically the addition method is not your best choice. This one, see how they look alike? X squareds, x, numbers, y over here. This says solve using substitution method, but actually the addition method probably just as easy, if not easier. This one, since they're completely different, substitution is better. This one, since they're completely different, substitution is usually better. Here's another one where they're exactly the same. X squareds, y squareds, numbers on this side. Usually addition method's easiest then. Okay. Well, our goal with the addition method is to, same as before, you add them together. And you may have to multiply the equations by numbers, because remember you have to have the same number in front of whatever you're trying to eliminate. Let's eliminate the y's, because this is already negative, this is positive, and they both have a 1 in front of them. So x squared plus x squared is 2x squared. Negative y squared plus y squared cancels. 12 plus 20 is 32. And then I'm going to divide both sides by 2. And we get x squared is equal to 16. Now square root property says we drop our squared and we put a plus or minus square root around the other side. And plus or minus square root of 16 is plus or minus 4. Now we then want to plug that back into one of our equations, each of these values. Doesn't matter which one, whichever one looks easiest to you. I'll pick the x squared plus y squared is equal to 20 because it doesn't have any negatives. And we just said that x is 4, so I'll put 4 in for x. 4 squared plus y squared is equal to 20. So we got 16 plus y squared is equal to 20. Take 16 to the right side, and we got y squared is equal to 20 minus 16, or y squared is equal to 4. Square root property, you drop your squared, and you put a plus or minus square root on the other side, and we get plus or minus 2. So our first answers will be 4, negative 2, and our next one will be 4, positive 2. Now I also want to do the same thing on the other answer. So I got x squared plus y squared is equal to 20. We're going to plug in negative 4 for the x. So we got negative 4 squared plus y squared is equal to 20. 16 plus y squared is equal to 20. Now notice they both have a 16. When you score something, it's always positive. So in this case, I don't have to work this side. This is going to give us the same y values. So the answers here will be negative 4, negative 2, and negative 4, positive 2. And those will be our 4 answers. Let me erase that. And let's take a look at inequalities and systems of inequalities. And after that, I'll take questions. We got y is less than 3x minus 1. We'll take a look at this one. Now, if you have a greater than or greater than or equal to, you want an upper right-hand triangle. If you got a less than or less than or equal to, you want a lower left-hand triangle. If you got a less than or greater than, it's going to be a dotted line, and we'll talk more about that. Less than or equal to or greater than or equal to, it'll be a solid. Now these are pretty much calculator-based problems if you can get y by itself on one side. Well, y is by itself on this one. So I'm going to go to my y equals, do a clear, and I'll put in 3x minus 1. Now notice where my cursor is. It's right here, and I want to go clear to the left. You can't go too far. It doesn't wrap around or anything. You want your flashing cursor on this first slash here. Now this is a less than. And we said a less than, we want a lower left-hand triangle. So I'll press enter one time, becomes a thick slash. One more time becomes a upper right-hand triangle. One more time becomes a lower left-hand triangle, which is what we wanted. Now the newer T84s are slightly different than this, but I think you'll figure it out. It'll drop down with a little menu, a little box where you can then choose that option. And then I'll push graph. Now the one thing it does not do is put either a solid or dotted line between the shaded and non-shaded region. You can do a dotted line, you just can't do a dotted line and shading at the same time. Well, since this is a less than is dotted. So, let's make a dotted line there. And then this side is shaded. And that's our answer. Now, it's specifically asking us about systems of inequalities. Let's say I had y is less than 3x minus 1. One we just got. But we also had another inequality. Y is greater than 5x plus 2. Well, we're going to put one of them on y1 and one of them on y2. So I'll go to my y equals. I already have y1 set up, so let me put in 5x plus 2. Go clear to the left, and since it's a greater than, we want an upper right-hand triangle. So press enter one time, becomes a thick slash, one more time becomes an upper right-hand triangle. And then we press graph. So there's our first one. And there's our second one. Now your answer is where they're both shaded. It looks like they're both shaded down here in this little region right here. So I'm going to come down here. And they're shaded right here. And that keeps going down forever. Now our answer is again where they're both shaded. So let me go ahead and stop that. I didn't show a linear programming example, but I don't think you have any trouble with that. It's kind of a combination of solving equations plus this graphing that we just looked at.